So 2016, number 6, another series question. And like I was saying in the last question, like they're defining the nth derivative rather than just giving you a function to derive over and over again. They don't want you to do that because they don't want you like memorizing like rules or anything. Let me see here. They want you to be able to build this from weird rules, I guess. They're giving you all the tools you need to find the nth derivatives. And this one is an explicit rule. Okay, whereas the last one we did was a recursive rule. But they're also giving me, so this says for n greater than or equal to 2, so I can find the second derivative and further. But I also know the first derivative at 1 is -1/2, and I know the value of the function at 1 is 1. So they want the first 4 non-zero terms. So again, I might just write out what the definition of the Taylor series is, just so I don't mess it up. Sometimes kids forget. Not just kids, sometimes I forget. The factorials on the bottom, sometimes you forget an exponent, whatever. So that should be the first 4 terms as long as they're all non-zero. So f of 1 is 1.
Why is it x minus 1 and then x minus 2?
I have no idea why. Thank you. I was looking at the 2 on the bottom of that while I'm talking here. There you go. They're all x minus center, right? Okay, so it's 1 plus, and f prime of 1 is -1/2, so it's actually 1 minus x minus 1. And then we need the second derivative, which we have to use this thing over here. So the second derivative is when n is 2, so that's -1 to the second times 2 minus 1 factorial over 2 squared. Woo. Okay. Right, because n is 2, yes. So that's -1 squared is 1. 2 minus 1 is 1, factorial is 1, over 2 squared is 4. So the second derivative is a fourth. So it's plus 1/4. You're still dividing by that 2 factorial, so that goes down into that denominator as well, squared. Okay, so we have 3 terms. They want 4, and they want the general term as well. So we got to find the third derivative now. And the third derivative, at 1 is -1 cubed. Well, that's just -1, right? Times 3 minus 1 is 2. And 2 factorial is just 2. Over 2 cubed is 8. So that's -1/4. So this is -1/4. You still have that 3 factorial down here. Okay? X minus 1 cubed. Now they also want the general term here, so check this out. We could try and see what the general term should be from here. See if there's some kind of pattern. It's kind of hard to pick up here. You see the n factorial, and you got this 2 and the 4 and the 4. But remember I reduced this to 2/8? Like it might be a little easier to not reduce it. But why I was talking about recursive and explicit a little while ago is because if you have an explicit formula for your derivatives, then you don't need to find the pattern here. Like last question, we had to find the pattern because we had a recursive formula, which is harder to you can't just drop that into our formula for the Taylor series. But I know that the general term for any Taylor series is the nth derivative at the center, which is 1, over the factorial times minus 1 to the n. Okay, so if I can't find the pattern, so they're going to make you do this several ways. Usually, you got 45 minutes this year, so maybe not. But they want you to be able to notice a pattern in the numbers. They also want you to be able to build it from like a definition they've given you. And because I know what the nth derivative at 1 is, I can plug that in for the nth derivative. So this becomes -1 to the n minus 1 factorial, and over 2 to the n. That's what the nth derivative is. They told me that. And then the n factorial is still down there, and then x minus 1 to the n. So that's the general term right there. But any Calc BC student who's worth their, I don't know what, who's good, knows that those factorials are going to cancel out. So this is just 2 to the n times n. There you go. And that's kind of hard to tell from up here, specifically because of this term here. We simplified that out, but if we had left it as 2 over 8 and simplified, like you would have seen that happening. But either way, so again, to highlight this, if you're given an explicit formula for the derivatives, even if you don't know what function it is, you can find the general term by just plugging that derivative expression into the general formula for a Taylor series. You should also be able to, in some questions, recognize the pattern and be able to write out what the pattern is in the general term, which we saw last question. So, hope everybody's okay with part A. B says, hey, guess what? We have a radius of 2. Okay, it's centered at 1. We have a radius of 2. Find the interval of convergence. Well, if we're centered at 1 with a radius of 2, we automatically know it's going to go down to -1 and up to 3. The question is, do we include those endpoints? And that's all they want us to check. That's why they told us the radius. If they didn't tell us the radius, we would have to do the ratio test to find it. All right, so we want to know if x is -1, this series becomes -1 to the n over 2 to the n times -2 to the n. That's what you get. So remember, this is our general term here, right up here. If you plug an endpoint in, -1 for x, that's what that becomes. And like I told you before, you should be simplifying out that negative part from the -2. So that's the same thing as this. All over 2 to the n times n. And you'll see what happens here is this becomes the -1 to the n, -1 to the n become -1 to the 2n. But that's just 1. Because you're squaring it all the time, so it's just 1. So this becomes, and the 2n's cancel, 1 over n. Just like we saw in the last question, you're going to say diverges because it's the harmonic series or by the p series with p equals 1. So we cannot include -1. Great. And if x equals the other endpoint, 3, then my series becomes -1 to the n over 2 to the n times n 2 to the n. Because we're plugging a 3 in here for this thing. So it becomes 2 to the n. So here you see the same thing happens. The 2 to the n's cancel, and we get the same exact series that we saw in the year before this. They want to know, does that converge? Okay. So this doesn't matter about absolute or conditional. It's just, does this converge at all? And we're going to say yes by the alternating series test, which I just wrote out a minute ago, but we'll do it again. No, equals 0. There's no n plus 1 there. There you go. And I'm all over the place here. Is the n plus 1 term less than the nth term? So yes, that's true. Yes, that's true. So you would write converges by the alternating, right, series test. Whew. Okay. So that's our interval of convergence. When they say show your work, they mean check the endpoints. Be quiet, you. All right. This is Taylor series for f about 1 can be used to represent f of 1.2 as an alternating series. Use the first 3 non-zero terms to approximate f of 1.2. So all that means is we're going to plug 1.2 into the first 3 terms, which goes up to the squared thing, right? So to be super duper lazy, look what I can do. Oh, look what I can do. That's the first 3 terms right there, right? Yes. Okay. So part C is just that, except we want to put a 1.2 into there, okay? So we'll I should have copied it, not done a screenshot. But either way, put a 1.2 into that, you get 0.2, which fractions are easier. That's a fifth, plus 1/8 times 0.2 squared. Well, that's 1/5 squared. That's 1/25. And you just leave it like that. And you would write f of 1.2 is approximately that. All right. So yeah, just like with tangent lines, if they ask you to approximate something with a tangent line or a Taylor series, just plug in the x value and just see whatever it equals. Cool. Show the approximation is within 0.001 of the exact value. And like we hope, this is alternating. So you just show that the next term, which I'm not going to write out again, all the reasoning for that. But the next term is just this right here. It's 1 24th. Cool. So 1 over 4 times 3. I'm just going to write it over here. So for part D, you would write because, blah, 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 because it's an alternating series with terms whose magnitudes decrease to 0. Or you can write because this is a convergent alternating series, the error bound is the first omitted term, blah, 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 which is 1 over 4 times 6, that's 3 factorial, times 1/5 cubed. All right, and that is 1 over 24 times 1 over 125, right? And what they want this to be is within 0.0001, and that happens to be less than 1/1000. Okay, not too shabby.